two coils P and S have mutual inductance, coefficient of mutual inductance 3 into 10 to the power minus 3 Henry. If the current in the coil P, is given by IP is equal to 20 sine of 50 pi t, 20 sine of 50 pi t, then the maximum value of EMF induced in the secondary coil ES is equal to question mark. ES is equal to question mark. Now, as dIP by dt is equal to, so here IP is this much, so therefore dIP by dt, differentiate with respect to time, differentiate this current, equation of current with respect to time. So dIP by dt is equal to 20. What is the ddt of sine 50 pi t? It is 50 pi into cos of 50 pi t, cos of 50 pi t, 50 pi into cos of 50 pi t, cos of 50 pi t. So dIP by dt we have to, now we know what is the formula for EMF induced across secondary. EMF induced across secondary is equal to coefficient of mutual inductance multiplied by what? Rate of change of primary current. Rate of change of primary current. M into dIP by dt, or that is equal to, what is coefficient of mutual inductance? It is 3 into 10 to the power minus 3 into dIP by dt is what? 20 into 50 pi into cos of 50 pi t, cos of 50 pi t, or this is equal to EMF induced across secondary is equal to 3 pi, see here 20 into 50, 1000 means 10 raised to 3 and 10 raised to minus 3, it becomes 1. So EMF induced across secondary is 3 pi into cos of 50 pi t, 3 pi into cos of 50 pi t. So if I compare this equation with the standard equation for alternating EMF, E equal to E0 sine of omega t, E equal to E0 sine of omega t, then we have E0 is equal to, what is the peak EMF? E0 is equal to 3 pi, E0 equal to 3 pi, that is equal to 3 into 3.14, that is equal to 9.42 volt, 9.42 volt. So the correct option for this question is option C. So C is the correct option for this question.